Welcome to our microprocessor and microcontroller courses, which expand on your digital knowledge and learning. We will be working with programming and interfacing, which is necessary to understand microcontrollers. As usual, our focus will be maintenance and repair from a technician's viewpoint. That means our focus will be the internal parts of the microcontroller, also called the architecture, basic programming at assembly language level, and interfacing I/O devices and using test equipment to figure out what is going on. The textbook used and can be found for purchase on Amazon. Searching for PIC Microcontroller Mazidi, that's Mazidi, on Amazon should get you there directly. Our screen shows that book, and at a fairly decent price. This quick introduction to the use of the textbook and other resources will get you to the level of knowledge needed. There are plenty of different microprocessor and microcontroller ICs, and we choose a representative one that will make it easy for you to transfer your knowledge to all of the others. Data sheets for microcontrollers are great resources, perhaps 300 pages or more of detail. They are hard to learn from, but excellent places to find detail. We will use a textbook for the microchip PIC 18 family of 8-bit microcontrollers as the guide for our learning and reference to the data sheets to get the details. The PIC microcontroller and embedded systems using assembly and C for PIC 18 textbook by Muhammad Ali Mazidi provides the background needed to support learning while also referring to the PIC 18F452 datasheet. Over 800 pages of textbook to assist your learning, plus more than 300 pages of datasheet. This book provides narrative, but its strength is example assembly language and C programming code. The code examples support the ultimate goal of learning the internal operation of a microcontroller at the level where a technician can use test equipment to resolve problems. The textbook starts with introductory materials on numbering systems and digital logic, which are a great review of the courses we completed last year. It continues by introducing microprocessors and microcontrollers, including an historical perspective. A microcontroller IC has a lot of internal complexity that is necessary to run a program and move signals back and forth to the outside world. This is referred to as the internal architecture and includes registers, buses, ALUs, memory, and all the basic combinational and sequential logic structures that we learned about last year. This is important to be familiar with, and we will approach this in a general fashion so that it can be applied to most other microcontrollers. The textbook deals with the PIC 18 family specifically. Once the internals are introduced, the textbook addresses assembly language programming to drive home the internal architecture specifics. It is fun learning programming and necessary to grasp it at a level for connecting with the internal operation of the IC. This is what a technician needs to fix microcontroller-based systems. The book continues to introduce the standard operating functions of a microcontroller using the specifics of the PIC 18 microcontroller and assembly language programming. Branches, loops, subroutines, program counter, arithmetic logic unit, program memory, data memory, and file registers are just some of the programming concepts covered. Hardware architecture and microcontroller components are some of the hardware topics that are covered. Remember, we will deal with the PIC 18 microcontroller specifics, but provide generalizations so that the things learned and can be applied to most microcontrollers and microprocessors. There are plenty of example programs to support your learning. There are many charts, lists, and other visuals, with some coming directly from the datasheet to support your efforts. Many of the more advanced programming examples also include high-level C programming example programs. The second half of the book deals with I/O interfaces of the microcontroller and their support for basic external hardware devices. The example assembly and C language programs continue to support this material. Before you know it, we are in over 600 pages or so and have used over 30% of the datasheet information to advance our knowledge to a level that lets us attack problems with microcontroller and microprocessor-based systems. Added to our learning efforts will be a number of activities, labs, and lectures along the way of becoming familiar with the ultimate part in digital electronics, the microcontroller and microprocessor. So, use the textbook as a learning guide and the datasheet as the specific and detailed information source. The textbook is necessary starter's guide where the datasheet becomes the source of information for the experienced technician. Once you get 2 or 3 different microcontrollers under your belt, you might only need the datasheet.